Assalamu alaikum. I am Muhammad Kamran Khalil from YouTube channel The Physics Gurus. After getting a wonderful response from O-level students, and they have asked me to make videos for the A-level physics. So I will start from A2, topic number 12, motion in a circle. So this is its first video. So it's part A, and in 1 or 2 days I will launch its part 2 as well. After that I will solve the topical papers. First I will solve the questions from the book, as well as the questions from the past papers. So first we will go through the its part 1. So the topic is the motion in circle. The learning objective for the 12.1 kinematics of uniform circular motion. So the first learning objective, before moving towards the first learning objective, uh, we have observed that there are so many things around us which are moving in a circle. The wheels of a car or a bicycle, that is the perfect example of a object moving in a circle. The earth, which is rotating around the sun, the electron revolving around the nucleus, the hands of a clock, a spinning DVD in a laptop, then the drum of a washing machine, because there is a motor, and when the motor will rotate, it means that there is a circular motion. So basically, in circular motion, there is a change in angle. Now, this particular one is the radius, and this segment from A up to B. This is the arc length. So S will be its arc length, and R will be its radius. Radius. Okay. Now the first thing is related with the syllabus, that define the radian and express angular displacement in radian. The first thing which you should know, that what is meant by the angular displacement. As I have already told you that whenever an object will move in a circular path, then there is change in angle. So when an object is moving in a straight line, then this is called the displacement, which is the shortest distance between 2 points in a particular direction. So that is the linear displacement. But with respect to the angular displacement, the angle theta through which the object has moved is known as angular displacement. So now it means that in this diagram, this angle is its angular displacement. Angular displacement. And obviously, from moving A to B, when there is change in the angle, it will take particular time to reach from A to B, after which there is change in angle. So the first thing you must know is the angular displacement. So the angle theta through which the object has moved is known as angular displacement. Now for circular motion, is angular displacement the angle of the arc through which the object has moved from its starting position. I have already explained it, that when we will move from A to B, then let's suppose initially there is angle 0, and then up till let's suppose there is a 60-degree angle. So that is the angular displacement. Now we will define the radian. This is a very particular and the important term related with the circular motion, that this definition I have taken from the past papers. The angle subtended at the center of the circle by an arc length which is equal to the radius of the circle. Now, what is meant by that 1 radian? Let's suppose the radius of this circle is 4 centimeter. So now moving from A to B, the arc length covered is also, which is represented by S, that is equal to 4 centimeter. it means that when the arc length is equal to the radius of the circle, then this change in angle, this angle which will subtended by moving from A to B, that particular angle is called as 1 radian. So for 1 radian, the arc length should be equal to the radius of the circle. The angles are measured in theta, but with respect to this, whenever we are dealing with the circle and the circular motion, it is more convenient that we will measure the angles and the angular displacement in units, which is called as the radians. So this is standard units. Instead of using the degrees, we will use the unit which is called as the radian. And I have already explained that what is meant by 1 radian. So now, the first formula related with the A2. If an object moves a distance s, I have explained it above diagram, around a circular path of radius r, its angular displacement theta is defined as. So, angular displacement is the length of the arc over the radius. So, angle is represented by symbol theta, the arc length is represented by the symbol S, and radius is represented by the symbol R. So very simple formula, S that is equal to R and theta. Now there is a relationship between R and theta because these are the two physical quantities which is having a multiple relationship with them. So it means that when the radius will increase, then the angle subtended will decrease, or when the radius will decrease, the angle subtended will increase. What is meant by that from the daily life? If I will give you the example of the sun and the example of the stars. The sun is there, the surface of the earth, as compared to the star. So the distance of the star is much greater than the distance of a sun. So this is the reason the stars seem to be a very tiny object, while the sun seems to be a very big as compared to the stars. So the radius and the angle are having inversely proportional relationship with each other. This is the relationship which I have told you because when I will go for the solution for the past papers, so there is a question which will uh, further clarify you that what is meant by this statement. So now the conversion is very important that in one complete rotation there is 360 degree, and that is equal to 2 pi radian. So 180 degree, that is equal to pi radian, 90 degrees pi by 2 radian, then 45 degrees pi by 4 radian, and so on. Now 1 radian, that is equal to 360 over 2 pi, or 1 radian, that is equal to 57.3 degree. So for a full circle, there is 2 pi radian. Now the conversion is very important. We are required to convert the angles to the radian, or degree to the radians, or radians to the degree. So there are two methods. If you want to convert from degree to the radian, then multiply that particular term by 2 pi over 360, or pi by 180, because 2 pi over 360 will give you pi by 180. And if you want to convert radian into degree, then simply multiply that particular value by 360 and divided it by 2 pi, or multiply it by 180 and divide it by pi. So this is the worked example. These examples I have taken from the second edition of the your course book recommended by the Cambridge University. So if theta that is equal to 60 degree, what is the value of the theta in the radian? So we will multiply 60 by 2 pi and divide it by 360. So answer will be 1.05 radian. Now we will move towards the next portion, is the angular speed. Angle swept out per unit time, or the rate of change of angle, is called as the angular speed. So this term has been asked in the past papers. So the exact definition I have taken from the mark scheme. So always remember one thing that try to learn the definitions from the mark scheme. Now the angular velocity. The angular velocity is represented by a symbol which is called as omega. So omega is the rate at which the angular displacement changes, or rate of change of angular displacement, rate of change of angular displacement, angular displacement is called as angular displacement is called as angular velocity. So angular velocity is represented by symbol omega. Omega that is equal to delta theta over delta t. Now the next thing is the relationship between the speed, angular velocity and radius. So the relationship between the speed, angular velocity and the radius is v that is equal to omega r. So first formula was s that is equal to r theta. Second formula omega that is equal to delta theta over delta t. Third formula omega that is equal to v over r. Now for one circumference, the angle rotated is 2 pi radian, and it will take time which is equal to the capital T, because capital T is the time which is required to complete one rotation, and during one rotation the angle covered is 2 pi radian. So this is another formula for the omega, but we know that 1 by t is equal to f. So this is another formula for the omega. So omega has four formula so far. Omega that is equal to delta theta over delta t, omega that is equal to v over r, omega that is equal to 2 pi over capital T mean period, and omega that is equal to 2 pi f. Now the worked example, uh, toy train travel around a circular track of radius 2.5 meter. Now the radius is given, then the time is given. He is asking about the speed. He is not asking about the angular speed. So now this is the point where many students will do mistake. So in order to calculate the speed, we must know that v that is equal to omega r, but we do not have the value of the omega, and we can calculate the value of the omega by using formula which are given above. So from above four formula, we will use this formula. So omega that is equal to 2 pi by t. A toy train travels around a circular track of radius. So it has completed one complete oscillation. So one complete rotation. So now, as shown in this example, the omega is 2 pi over 40, so 0.157, and the other one is the, now we will apply the formula v that's equal to omega r. So we will get the answer 0.39. What do you think? Is there any other way to solve this question? Can we solve the value of v directly? Okay. Now the v is velocity. Velocity is for the circumference for one complete rotation. So 2 pi r divided by time. So we can calculate, yes, there is another solution for this question which we can do directly. So 2 into pi into radius is already in meter 2.5, and then divided by time, and what is the value of the time given is 40 seconds. So we will get the same answer, that is 0.39 meter per second. So I hope that you have good concept of this first phase. Now we will move to the, okay, so recall and use omega that's equal to 2 pi by t, v equal to r omega. Now we will move towards some practice questions. The angular velocity of a hand clock is omega. The value of omega is given. That is equal to 0.105 radian. per second. Now length is given, means radius is given 1.8 centimeter. It should be in meter, so 1.8 divided by 100 gives you 0.018 meter. He is asking that speed, so it means that V is required. So V equal to omega r. Now the angle is given in radian. So for velocity, the angle should be in degree. Let's move upward. So when the radian is given and you want to convert into degree, from a radian into degree, just multiply it by, convert from radian to degree. So whatever the value is given, multiply it by 360 and divide it by 2 pi. So we will do multiply by 360, 0.105 multiply by 360 and divided by 2 pi. Let's see what is the answer. So 0.105 multiplied by 360 divided by 2 divided by pi. The angle is 6 degree. So now we will calculate the answer. V that is equal to 6 multiplied by 0.018 multiplied by 0.018. So answer is 0.11 meter per second. So this is the speed which is required to calculate. The other one is the question. Now this is a good question. A car travels around a 90 degree. Now the degree is given, theta that is equal to 90 degree. Time is given, radius is given. He is saying that angular velocity omega that is equal to delta theta over delta t. Okay, now conversion. We will move again to the upward content. Now, whenever you want to convert degree into radian, do the reverse process. Now, multiply the value by 2 pi and divide it by 360. So, multiply by 2 pi divided by 360. So 180 over 360 pi. So that is equal to pi by 2 radian. So now angular velocity omega that is equal to pi by 2 radian divided by, what is the time, 15. Okay. So pi divided by 2 and then divided by 15. We will get the answer 0.10. So 0.10 radian per second. He is saying that determine the speed of the car. V equal to omega r. So 0.104 multiplied by 50. Multiplied by 50. So 5.24 meter per second is the answer of this question. Okay, Jia. The last practice question: a spacecraft orbit the Earth in a circular path of radius. The radius is given 7,000 kilometer. So kilometer should convert it into meter. 1, 2, 3 meter. Okay. Speed V is given 7,800 meter per second. He is saying what is the value of the omega. So we know V equal to R omega that is equal to V over R. So 7,800 divided by 1, 2, 3, 4, 5, 6. Let's see what is the answer for this question. 7800 divided by 7, 1, 2, 3, 4, 5, 6. So I got the answer 1.11 into 10 is power minus 3. So omega dash is equal to 1.11 into 10 raised power minus 3 radian per second. So students, these are some practice questions related with the topic, and I hope so that now you have a good understanding of the first part of the circular motion. So stay tuned for the next topic and the topical paper as well. Take care. Allah Hafiz.